Hello, I'm going to share to you how to tackle these questions. First, we have two elements. V and W are adjacent group in periodic table. V reacts with oxygen to form acidic gas of X. So basically, you have a V plus oxygen to give VO something, all right? So which is actually acidic. So if you have an acidic gas, then basically this one comes from probably can be in the form of from group 5, right, or group 17, or also group 16, all right. But the thing is here, it says that V um, forms an anion with the formula of VOM minus, all right. So I presume that, for example, if we have a something, for example, if we choose nitrogen, okay, and then when nitrogen reacts with oxygen, for example, to give NO, all right, or let's say NO2, all right. So I'm pretty sure that we have a 2 here, and this one is actually 2, all right. So we have a acidic, actually we have actually acidic gas. So acidic gas, and then the reason why I pick nitrogen, because it says that the anion given is actually VOM minus. So if I use NO2 and I draw the dot and cross diagram for NO minus, then I will have this one, right? So nitrogen is in group 5, so that will be 1, 2, 3, 4, and 5 of nitrogen. And then I have a 1, 2, 3, 4, 5, 6 of oxygen, and 1, 2, 3, 4, 5, 6 of oxygen. Hey, I still have a lone electron here. So I need to add something. For example, I use triangle. Then when I get this triangle, then the overall charge of this molecule will be -1. All right, so that's why it also increases my hypothesis that V probably nitrogen. All right, because it says the um, um, atom, so it's actually nitrogen atom. And then X is actually, in my perspective, I can put actually NO2 or NO, all right. And then M is actually the number of oxygen atom. So in this case, I have a, it can be 2, all right. So NO2, all right. Now, next is, let me clear up my, okay, so, and the other one is actually W reacts with oxygen, right? So W reacts with oxygen to give acidic gas of Y. So let's say I have Y, and this Y is actually acidic. Subsequently, W forms an ion to form WON2 minus. So up to my knowledge, so we have actually SO4 2 minus. We also have a SO3 2 minus, right? And then the other possible 2 minus charge is actually SO4 and SO3. All right, so I presume that this one is actually S. So my hypothesis, I would say W is actually S, all right, or sulfur, all right, and then or S, and then Y is actually, yeah, I would say probably, yeah, let's say you have a S plus O2 to give, can be in the form of SO2, can be also in the form of SO3. So I'll just write SO2 or SO3. All right. Now, the reason why I pick the substance actually sulfur, first and foremost, because it says that I have a 2 minus charge. Okay, 2 minus charge. Sulfate, and sulfite has a -2 charge. All right. So it directs my attentions that the component or the identity of W is sulfur, right? So, and then the next things I need to prove whether my my hypothesis is supported or refuted at the end of the day. All right, so how do I prove it? So it says that a solutions of WON 2 minus forms a white PPT. All right, so it's obvious here it's actually white PPT with Ba aqueous, so means that I have a barium that I dissolve in water, but shows no visible reactions with Mg. All right, so it is actually valuable for us to note that we have a, when we look at periodic table, so in group 2 we have a beryllium, magnesium, calcium, strontium, and barium. All right, so as you um, if you remember, right, so down the group, solubility of group 2 decreases down the group. Okay, so solubility of sulfate decreases, right, decreases down the group. All right, so meaning if you have a Ba 2 plus SO4 2 minus, then it will immediately to give precipitation. So there will be precipitate. Okay, so and the color of this precipitate is actually white. All right, so but then you might ask me why with Mg is no visible reaction, because basically if you go back to our tutorial, right, so if you know that we have a value of delta H, right, solution, all right, and then we also have delta H lattice energy, all right, and then we have a lattice, so excuse me, so I'll just erase this one. So if you remember the solubility of ionic compound, all right, it becomes more soluble if the value of delta H solution is negative, all right, meaning if you have the value of delta H solution is positive or endo, meaning that the ionic compound will be less soluble, or even it will give you precipitation. All right, so all right, so if you remember, lattice energy is actually Q1 times Q2 divided by R squared, meaning if you go down the group, all right, if we go down the group, the value of the lattice energy becomes more endo. All right, so this one, so sorry, exo. So this one, if this radius increases, right, the lattice energy decreases. So it means that uh, value of lattice energy will decreases as the size of ion increases. All right. Now, if you remember that down the group of this lattice energy down the group, okay, decreases. Okay, so it means that it becomes more exo, or sorry, more endo. All right, and then hydration also decreases, meaning it is actually more endo. All right, and then therefore also it will affect the value of delta H solution. Delta H, all right, delta H solution also decreases, meaning it becomes more endo. All right, okay, bear in mind, but when you talk about solubility of sulfate, always remember that delta H hydration decreases more than the value of delta H lattice. Okay, so you have to remember that fact that actually delta H hydration for sulfate is decreases greater than the delta H lattice energy of group 2 sulfate. All right, so I hope my explanation helps you to tackle these questions. Thank you.